Can you survive on the planet Mars? Well, first and foremost, you'd need a way to get there. But be prepared for a 9-month journey according to NASA, and that's just for a one-way trip. Once there, all you'd have is your spacesuit and the spaceship that carried you down. But unlike Earth, with 21% oxygen at sea level, Mars has a measly 0.13% oxygen. What isn't measly on Mars is carbon dioxide, or CO2. This makes up about 95% of the atmosphere on Mars. So in order to breathe, you'd need a device called MOXIE, which uses an electrochemical process to break the oxygen, or O2, off of the CO2. But now we run into our second problem, which is containing that oxygen. For this, you'd need a pressurized habitat that's connected to the MOXIE, but not just any old habitat will do. That's because Mars has a thin atmosphere and lacks a magnetic field like Earth. As a result, Mars is constantly bombarded with radiation from solar flares and cosmic rays, which makes its surface inhospitable to long-term human life. But if you built your structure deep underground or used thick radiation shielding, likely with hydrogen-rich materials, you could stay protected. So at this point, you have breathable air and radiation protection, but these will only keep you alive for so long. That's because you still don't have a reliable source of food and water. So starting with the more immediate need, water, you'd need a little bit of machinery. You see, most people think Mars is just a dry and dusty planet, and they're not wrong. But beneath certain parts of the surface is actually ice. And if you dig deep enough, researchers now believe you'd find aquifers with liquid water. Of course, the ice that's closer to the surface would be easier to reach, which is where the machinery would come into play. You'd need to harvest the ice, then melt it, but it still wouldn't be drinkable water because this ice is packed with perchlorates, chemicals that are toxic to humans. So you'd need a bioreactor to purify the water to make it drinkable. With this water, you'd have the first part of our next problem solved: food. Unlike on Earth, you can't just plant seeds in the Martian soil and expect to see any growth. Instead, you'd need a temperature-controlled environment and vertical farming pods, which is a method to grow plants in nutrient-rich water, not soil. With all of these essentials taken care of, it might seem like we have everything we need to survive on Mars. There's just one glaring problem we've overlooked this entire time, which is energy. At this point, we have a pressurized habitat, a MOXIE, a bioreactor, and heavy machinery to mine ice, all of which require a power source. Fortunately, we have a range of options when it comes to power generation on Mars. Your best bet would be a nuclear reactor, though you could also use solar panels as a secondary source, which is secondary because of dust storms and darkness, each of which limit the yield from these solar panels. These would allow you to power the food, water, and shelter that comprise the essentials of daily life. If all of this feels like an extreme uphill battle, you'd be right. But even though Mars may not make sense to colonize, it would be a great testing ground for colonizing planets that are further away. And because of advancements in landing technology, life-sustaining research, and space exploration in general, we're closer now than ever before to making Mars colonization a reality. Do you think this is a good idea? Let me know in the comments.